Kavya PM. I am here to give presentation about our project AI-powered detection and classification of diabetic retinopathy using deep learning algorithms. Introduction. Diabetic retinopathy is one of the most common complications of diabetes that affects the blood vessels in the retina. Diabetic retinopathy means it is a serious eye disease that affects the blood vessels in the retina of the diabetic patient. It occurs when high blood glucose levels cause damage to the tiny blood vessels that nourishes the retina. These damaged vessels can swell, leak fluid, or close off completely. In advanced stages, abnormal new blood vessels can grow on the retinal surface. There can be cause severe vision loss and even blindness if left untreated. According to the global health statistics, approximately 3.9 million people worldwide are affected by diabetic retinopathy, with the numbers projected to increase as diabetes prevalence rises. The condition is classified into five distinct stages based on the vascular abnormalities and their manifestation on the retina. Each stage represents the progression of disease. No diabetic retinopathy. In this stage, no visible abnormalities in the retina. Blood vessels appear normal with no sign of hemorrhages. Regular retinal examination is still recommended for this diabetic patient at this stage. The retina has a normal blood flow and oxygenation. Second one, mild non-proliferative diabetic retinopathy. In this stage, it is characterized by the presence of tiny blood clots on the retina. Patients maintain normal vision. Early warning signs that diabetes is affecting blood vessels. Third one, moderate non-proliferative diabetic retinopathy. In this stage, more extensive and hemorrhages, yellowish deposit of lipids and proteins, cotton wool spots may develop. Some blood vessels start to get blocked. Fourth one, severe non-proliferative diabetic retinopathy. Many blood vessels start to get blocked. Retina is deprived of oxygen, high risk of progressing to proliferative stage. Fifth one, proliferative diabetic retinopathy. It is the last stage of diabetic retinopathy. It is the advanced stage. New abnormal blood vessels form. The new vessels are fragile and can break easily, causing vitreous hemorrhage. Fibrovascular tissue formation that can lead to retinal detachment. Potential for severe vision loss or blindness on the retina. Early detection and accurate diagnosis of diabetic retinopathy are crucial for timely intervention and effective management. Yet the traditional screening process relies on the expertise of the ophthalmologist to interpret fundus images, which can be time consuming and subjective. This project is aimed to develop an AI-powered system using deep learning approaches, specifically transfer learning with convolutional neural network, to automatically detect and classify the five stages of diabetic retinopathy from fundus images. These are the IEEE papers we referred for our project. Transfer Learning in Diabetic Retinopathy Classification, published in the year 2021 by the author Words et al. Deep Learning for Early Detection of Diabetic Retinopathy, published in the year 2020 by Goshen et al. Third one, Diabetic Retinopathy Detection using CNN, published in the year 2019 by Prats et al. Next, continued by yogapriya.
I am yogapriya. Coming to the problem statement, the diagnosis of diabetic retinopathy is a significant healthcare challenge worldwide. It relies heavily on specialized medical expertise, which is not always easily accessible. Even among trained ophthalmologists, there can be interobservable variability. Two experts might interpret the same retinal image differently and consume significant time and resources. Early diabetic retinopathy often lacks symptoms, delaying diagnosis and treatment. There is a global shortage of eye care professionals. This shortage is especially severe in rural regions, which further limits access of timely screening. The project aims to develop an automated deep learning-based system capable of accurately detecting and classifying the five stages of diabetic retinopathy, thereby improving the screening reach, reducing diagnostic time, and enabling early intervention to prevent the vision loss. Coming to the objectives, the first goal of is to develop a deep learning based model capable of detecting and classifying the diabetic retinopathy. The five stages are no DR, mild DR, moderate DR, severe DR, and proliferative DR. Instead of building a model from scratch, the project uses transfer learning techniques, which helps to reduce training time and improve the accuracy. Coming to the data processing and augmentation techniques to model robustness and performance. Data preprocessing includes resizing, Context enhancements. Data augmentation includes rotating, flipping, and zooming. These techniques are especially used for handling class imbalance. To create a user-friendly interface that can assist healthcare professionals in the screening and diagnosis of diabetic retinopathy. For example, upload the retinal images easily, receive instant classification results showing the DR stage. Coming to the scope of the project, automated medical diagnosis support. Assist the ophthalmologist by automating DR screening and reducing the diagnosis time, and it reduces the manual workload on specialists. Multi-stage classification. The system is trained to classify images across all five stages with high accuracy. Enhancing rural and remote healthcare. Many rural and remote areas suffer from a shortage of ophthalmologists. Our system allows non-specialist healthcare workers to capture retinal images. Coming to the educational and research applications, beyond diagnosis, the system has strong educational value. Medical students and tiny ophthalmologists can use it to study diabetic retinopathy images and understand the disease progression. Global health impact. By enabling the scalable, affordable, and accessible screening, the system contributes to global blindness prevention programs. It is especially impactful in low research settings. Over to Meghna.
About methodology of our project. The first step is a data collection. The first step involves gathering a comprehensive data set of retinal fundus images, which is obtained from Kaggle website. Each image is typically labeled with a grade of diabetic retinopathy, which include no DR, mild DR, moderate DR, severe DR, proliferative DR. Proper labeling is crucial for supervised learning. And the second step is the data pre-processing. Raw medical images may vary in size, quality, and lighting conditions. Pre-processing helps standardize these images into for a effective model training, like resizing all images to a fixed dimension, example 224 into 224 or 512 into 512 pixels, and the normalization of pixel values to a standard range, example 0 to 1 or 1 to 0, like that, and the noise removal using filters. And the third step is data augmentation. To increase the diversity of the data set and to reduce overfitting, augmentation techniques are applied, techniques. Some of the techniques like rotation at various angles, horizontal or vertical flipping, zooming, cropping, and translation, and brightness and contrast variation. Augmentation simulates different clinical scenarios, improving the model's robustness. And the fourth step is model development. The core of the methodology is designing or selecting an appropriate deep learning architecture, typically a convolutional neural network, due to its excellence in image tasks. And the fifth step is training process. The model is trained using a training dataset with labels like loss function, example categorical class entropy is optimized. Optimizers like Adam are used for gradient descent. Use of validation set to monitor for overfitting and adjust training. And the sixth step is model evaluation. After training, the model performance is assessed using accuracy. Accuracy means overall correctness of predictions, and the precision and recall, which is nothing but especially critical in medical diagnostics. And the F1 score, which is for harmonic mean of precision and recall, and the confusion matrix, which visualizes performance for each class. This helps to identify biases or weaknesses in classification. And the seventh step is system integration. Small network issue. And the system integration, the trained model is embedded into a practical system such as desktop or web application, or a integration with medical imaging devices. The interface allows uploading new retinal images, automatic DR stage prediction. And the eighth step is validation and testing. Final model is evaluated on the independent test set that was not seen during training. Real world testing with data from different sources or hospitals, like robustness and generalization across populations are checked. And the final step is final DR classification model, which where the output is fully trained, validated, and an integrated deep learning model that can detect and classify diabetic retinopathy stages accurately, serve as a diagnostic aid for ophthalmologists, and potentially be deployed in a telemedicine or rural healthcare setups. Thank you. Over to Lavanya.
I am Lavanya GS, hardware and software requirements. Software requirements. To develop this project, we used a set of software tools. We built our project on Windows 10, which supports deep learning frameworks. For coding, we used IDE environments like Visual Studio Code. The programming language chosen was Python 3.8 or later, since it has excellent support for machine learning. For the deep learning part, we used TensorFlow, PyTorch, and scikit-learn. For handling and visualizing data, we used NumPy, Pandas, Matplotlib, and Seaborn. Finally, for deployment, we plan to use Flask so that users can access the system through a simple web interface. Next, hardware requirements. Since deep learning requires high computational power, we also need good hardware support. A CPU like Intel Core i5 8th generation or higher, at least 16 GB of RAM is required to handle large image datasets. A 512 GB SSD ensures faster data processing and storage. Next, coming to the expected outcome. Our project follows a step-by-step workflow. The first step is input. We collect the retinal fundus images from patients. The second step is pre-processing. Here we resize images, rotate them by 90 degree, 180 degree or 270 degrees and also flip them. This process is called data augmentation and it helps improve the training of our deep learning model by making it more robust. The third step is feature extraction. We use a convolutional neural network to automatically detect and extract important features from the retinal images such as blood vessel patterns and hemorrhages. The fourth step is classification. The features are passed into a CNN to predict the stage of the diabetic retinopathy. Finally, the fifth step is output. The system classifies the images into one of five categories: no DR, mild, moderate, severe, or proliferate DR. Here we can see the diagram of the diabetic retinopathy detection. The diagram illustrates our system pipeline. As you can see, an image goes through pre-processing, then into the CNN for feature extraction, followed by classification, and finally the system outputs the DR stage. On the right hand side, you can see examples of retinal images labeled as no DR, mild, moderate, severe, and proliferate DR. Key benefits of the diabetic retinopathy detection or early detection of diabetic retinopathy. It provides the automation, reducing the workload on doctors. It improves accuracy by using deep learning. And finally, it can be scaled and deployed in real-world hospital environments as a web application.
Meet my teammates. Meet my teammates. Now here, like we have so many features. Like you can see here, AI-powered analysis, image enhancement, user-friendly interface, real-time processing, and history tracking. And we have help center, and then about like once we provide your email and password. I have entered it, and then click sign in. Once you have logged in successfully, it will show login successful. And now upload image. I will choose 10 left. Once the image is uploaded, click predict. It will take some time. Yeah, you can see here it shows no DR, confidence 0.0%. We can delete it or we can edit it, and here is the prediction history. And we have AI chatbot. We can share our problems and find solutions. That's it. And then finally we can log out here. Thank you.